Okay, yay, having so much fun. Right, z equals negative 4 times the square root of 3 minus 4i in polar form. So for polar form, there's two things you need. You need the r and you need the theta, right? And so r is the square root of a squared plus excuse me, b squared. Okay, so remember that rectangular form is a plus bi, and then theta is the inverse of tangent of b over a. So r equals the square root of negative 4 square root of 3 squared plus negative 4 squared. So negative 4 square root of 3, well, 4 to the second power is 16, and the square root of 3 to the second power is 3. So 3 times 16 is 48, plus 4 squared, that's what, 16. And then that's going to be the square root of 64. Excuse me. I ran out of room, so let's rewrite this. So negative 4 square root of 3 squared plus negative 4 squared. That's going to be square root of 48 plus 16, that is the square root of 64, which is 8. So my r is 8, and now I got tangent inverse of negative 4 over negative negative 4 square root of 3. Well, the negative 4's cancel each other out, so I'm just going to have tangent, or the inverse of tangent, of 1 over the square root of 3. Now, if you check your handy dandy chart, you'll see that 1 over the square root of 3, right, is 30 degrees. And then I want to change that to radians, so that's pi over 6. And so now I'm going to take those two things and I'm going to put them in my polar form. That's polar form, by the way. So that's going to be 8 times cosine of pi over 6 plus I sine pi over 6. That's my answer. Now I got to do the same thing. Polar form, I want to change it to rectangular form. So I know that A equals R times cosine of theta, and B equals R sine of theta. Excuse me. So my R in this case is right here, and then there's my theta. So I'm just gonna do that. So A equals 4 times the square root of 2 times cosine of 3 pi over 2. So I'll take my my unit circle and I look up 3 pi over 2. 3 pi over 2 is 270 degrees. And so if I look, cosine of 270 degrees is 0. Sine of 270 degrees is -1. So that's going to be A equals 4 times the square root of 2 over, let's say cosine was 0. So A equals 0. All right, and then I'm going to do the same for B. So B equals 4 times the square root of 2 times sine of 3 pi over 2. Well, what did we just say what 3 pi over 2 was? Or sine of 3 pi over 2? It's -1 times 4 times the square root of 2. So then B is going to equal -4 times the square root of 2. And so then finish up, I got A plus B times I. A is 0, so I'm going to add 0 plus, well, let's say 0 minus, excuse me, -4 square root of 2. And then I got to put an I in there, so let's put it in right here. So that's going to be -4i times the square root of 2. So that's my answer, is -4i times the square root of 2. Don't like the way that looks. Let's see if we can clear that up. Okay. Ah, shucks. Okay. So here we go. There are 15. Well, choose whether each situation utilizes permutation or combination, and then find the number of possibilities. There are 15 applications for 4 computer jobs: programmer, tester, engineer, and manager. All right. And so, is that a permutation or a combination? Well, let's remember what a permutation is and what's a combination. So what were we saying? Did a combination, order doesn't matter. So I'm just going to have several spots. But a permutation, order does matter because my spot is specific to a certain thing. Well, that's what we got. We got a programmer, so that's specific. I got a tester, that's specific. I got an engineer and a manager. So if I fill up the programmer's spot first, then I'm not going to have a spot for another programmer. So that means it's a permutation. And the formula for a permutation was, see, okay, come on, first, let's remember this. What was it? Oops. Darn it. C n equals factorial of C minus n factorial. So in this case, C is 15, n is 4. Let's see. So remember what that means. That's 15 times 14 times 13 times 12 times 11 over 11. So So this and this cancel each other out, and then I just got these four values. Got 15 times 14 times 13 times 12. That ends up being 32,760. All right, so now we're on to the next one. A group of 20 people are going to run a race. The top 5 finishers will advance to the finals. We'll see, here we go. The top 5 finishers. See, that's not specific. So I've got the person who crosses the finish line first, and second, and third. But see, it doesn't matter. The order doesn't matter. And if the order doesn't matter, then we're talking about a combination. So, C. And I got 20 and 5. So that formula is C factorial over n factorial times C minus n factorial. So that's, oops, not 15. That's 20 factorial over 5 factorial. What is that? 20 minus, so that's 15. So that's going to be 20 times 19 times 18 times 17 times 16 times 15 factorial over 5 factorial. That's 15 factorial. So the 15s cancel each other out. And so what is 5 factorial? That's 5 times 4 times 3 times 2 times 1. Well, the 1 doesn't matter, but now I can just start like canceling. So let me make it a bit more apparent. I've got 20 is 19 times 18 times 17 times 16 over times 4 times 3 times 2, and the 1 don't matter. So I can say 5 divides 5, or 5 goes into 20 4 times. Cancel that off and put the 4 there. Can mess with 19. Let's say 18. I can say 3 goes in there. 3 goes in there. So that 6 times. So that's 6. That goes away. And then 16, 4 goes in there. 4 goes in there 4 times. So then that's times 17, all divided by 2. Okay, so if I multiply all that out, and I gotta find a spot to the side, just a second. I gotta decide whether I'm going to use a calculator or not. Okay, so 19 times 4 times 6 times 17. Okay, so that's going to be 31,008 divided by 2. So that's going to be 15,504. And that 4 looks like a 9, so let's get that right. Okay. All right, and we got one more. So we're talking about pizza now. Pizza, pizza, pizza. So I'm a customer. I'll select 3 toppings. Okay. um, from 9 different topping choices. Okay, 9 different topping choices. Let's see, for a pizza supreme. Ooh, pizza supreme. So, is that a permutation or a combination? Well, so we got specific toppings. If I pick pepperoni, I'm not picking pepperoni again. And the order matters, because if I pick pepperoni first, then I'm not picking pepperoni again. If I pick sausage first, I'm not picking sausage again. So that's going to be a permutation. And so that's a permutation 9, 3. So that's going to be 9 factorial over 6 factorial. And so that's going to be 9 times 8 times 7 times 6 over 6 factorial. 6's cancel each other out. And I got 9 times 8 times 7. That's 72. 72 times 7. So that's 504. That's my answer. All right. And then finally, evaluating. Ooh, unit circle time. So, clue you in on a couple things. So one of the things you need to think about with this is, I know 2 pi is 360 degrees, is one rotation, right? And so if I'm looking at that, and I see that 6 is in my denominator, if 6 is in my denominator, what would the top be for one rotation? 12 pi. And one of the laws that we got for these things is that if I have 2 pi times n plus theta, that of sine, cosine, or tangent, that my answer is just sine, cosine, or tangent of theta. Because see, the rotation kind of cancels itself out. See, I got a unit circle. Yep, right here. Okay, so like for instance, from 0 all the way around to 360 degrees, that's one rotation. And then if I go, if I go right here, the only thing that becomes relevant is this piece right here. So if I have 2 pi plus pi over 6, this is the only part that becomes relevant, because that takes me back to 0. And so then I'm looking at sine or cosine or tangent of just this, right? But it has to be 2 times that. So like if I go from here and go all the way around, and then I go right to here, that's pi. So I'm gonna have 2 pi plus pi. So then the pi is relevant, right? So the 2 pi is what I can kind of factor out. So let's put what we got in practice. All right, so I got 25 over 6. Well, I know that 12 pi over 6 is 2. So if I think about, let's say 4 pi, so that's 24 pi over 6. Plus what to get that? Pi over 6. See, so this right here represents 2 pi, so that's 1 revolution, and then another 2 pi, so that's 2 revolutions, or 2 cycles. So I went 360, 360, and then I went pi over 6. So that's the only part that's relevant. And so cosine of pi over 6 equals square root of 3 over 2. So that's my answer. So now I'm looking at thirds. So, well, 2 pi for thirds is what, 6 pi? So how many times is 6 going to go in there? 6 goes in there 12 times. So it's 12 pi over 6 plus, and then how many are left over? 5 pi over 6. So let's go over here. I'm looking for 5 pi over 6. So revolution, 5 pi over 6. Right there. So after a revolution, I get to 150 degrees, and I'm looking at what? Sine? Sine of 150 degrees is 1/2. And finally, tangent. Well, there's two parts to tangent, because you can't forget the tangent is sine of theta over cosine of theta. So I'm going to have to put the sine and that cosine over there. So that's fourths. So that's 2 pi equals 8 pi over 4. Well, that's 7. So that's not going to work because that's too much. So let's think about where we're at. We're starting here, and we go right here. Oh, we didn't even make it one revolution. See? 7 pi over 4. So that's 315. And so sine of that is negative square root of 2 over 2. And then cosine of that is a square root of 2 over 2. It's both the same, but see there's only one negative, so my answer is -1. Because remember, that's sine divided by cosine. So this problem, it didn't even make one full revolution. And that's that page. And let's stop this one and